Um, JRuby internals. First, for those people who don't know me, I'm known as one of the JRuby guys. I'm a core developer on the JRuby project. For about the last year, I've been working at Engine Yard, and they've been gracious enough to let me work on JRuby as my day job, along with Charles Nutter and Nick Seeger. 3 years before that, Sun Microsystems let me work on JRuby as my day job. Thanks to them / Oracle, whoever. But before that, I did it as a hobby, and it was my nights and weekend passion, and it actually turned into a job for me. And you should keep that in mind for the rest of this talk. A couple other stats. I've been using Ruby for almost 10 years, which is kind of frightening. I've been using Java since the beginning. So when I was asked to come here, there was a list of really technical stuff. And I just sort of wrote back, oh, I'll do a JRuby internals talk. How tough can that be, right? As it turns out, it's really, really hard. So I had a few false starts, and then I'm like, damn, I better have a plan B. And so plan B was actually going over Hiroshi Nakamura's JRuby hacking guide Prezi presentation. And the thing is just absolutely awesome. I have the URL here, and I also have it at the end of the talk. Check it out. You can just like pan in and navigate around, and there's all these circles, and there'll be like comments instead of an O, and it just looks awesome. And I got a chance to see this talk at JRuby Kaigi, so it seemed like a good idea. But then I realized he did it in Japanese, and I had no idea what he was saying. On top of that, I started going through the slides, and I kind of realized that about half of them are probably stuff that I would never talk about because that code is essentially done. And if you're going to be hacking on JRuby, you're just not going to be entering those portions. So then I started looking for plan C, and then I'm like, well, how big is our code base anyways? And this freaked me out. We have 250,000 lines of Java code right now. And we have pretty much that many lines of Ruby code, but I excluded the 1.9 standard library because it's close enough to 1.8 that I would have been cheating a little bit. But then that made me a little bit nervous about this talk because it's only 30 minutes long. And now I've probably wasted about 3 minutes doing a meta talk on the talk I haven't given yet. So I decided to go and narrow the focus of this talk down to internals that could help you if you decided to become a new contributor to JRuby. Like I said earlier, I started out as someone who just wanted to work on an open source project. So hopefully this will help give you the motivation or at least the knowledge to get started. The first thing that you do as a contributor is you'd go and download the source. You can get it from GitHub. It's not actually our actual source, but we have some post-commit hooks, so it's only about 2 seconds out of date. But the advantage of actually getting it from GitHub instead of the real source is that you can then send us pull requests. If you're on Apple, how many people are PC users, by the way? Linux? Oh. Okay, I crossed some semantic boundary here. How many people are Mac users? That's a different... Okay, almost everyone. So Java's already installed, even though it's deprecated. And all you have to do is figure out how to install Ant. You can download it from their website. If you use Mac ports, I believe they have it. And Homebrew probably has a recipe. I don't know. But once you actually get it installed, all you have to do to build JRuby is just type Ant. It'll completely build the project. And then if you change one line, you've suddenly become a JRuby hacker. So it's very easy to get involved technically. The other thing that I thought about is what should people work on if they're first contributing to JRuby. 85% of the people generally scratch their own itch. They find a problem in JRuby, they file a bug, maybe a week goes by and they're like, God, I want this fixed. And they dive in, and they pretty much universally get it fixed, at least the people we end up talking to. I didn't actually start that way. When I started at JRuby, there was a single production user, and it wasn't me. So I just started looking at bugs that were listed, and I started digging in. And actually, this isn't a bad way for getting started because there's already the context. There's usually a little script that produces the actual problem, and there's someone you can talk to in the bug when you get stuck. And this kind of goes to the next point. You should have no fear when you get involved with an open source project because no one really knows anything about an open source project when they first get started. A secondary fear that a lot of people have is, I'm a Rubyist, I don't know Java. Big deal. Java is so simple that it's your freshman level language course. I mean, how tough can it be? But if you do get stuck, you can always come onto our IRC channel, you can join our mailing list, you can comment on the bug. And now for the rest of this talk, I'm going to talk about some details of internals, and hopefully by the end of this you won't think that these are particularly difficult to understand. For most people who work on JRuby and contribute to it, they spend all their time in one package, org.jruby. In particular, they work on a class that starts with Ruby and ends with Java. Probably the biggest class is Ruby itself. This is the main context for an individual runtime. Notice that I say it's an individual runtime. With JRuby, you can run multiple instances of Ruby runtimes. In fact, this is how we support JRuby on Rails with multiple listeners when you're not in thread safe mode. We just fire up n instances. Because it has a context object, it has absolutely everything important that is needed for the runtime to exist. It has hard references to the class hierarchy, and by extension, all the objects that are still alive. It stores stuff like in, out, and error streams, finalizers, object space if you're crazy enough to have that enabled. But as a new contributor, you spend a lot of time in this class because there's some friendly methods for getting and creating objects. So you can do runtime.getObject to get a reference to Ruby's object class. Or you can type runtime.newFixNum to go and get a new fixnum object, which might be backed by an actual fixnum cache. So you'll frequently be calling into this class. Some people call this an anti-pattern. I just live with it. So now I'm going to talk a little bit about bootstrapping the runtime, in particular how core classes get bootstrapped. When you create a new instance, it calls a method newInstance, which calls init, which calls bootstrap, which calls init core. And the point of this is we bootstrap a lot of stuff. But as a new contributor, the thing that's most important is actually fixing bugs on the core classes, because there's all these little corner case bugs that are still out there lurking. If you look at the if statement, this is a special ability we have where you can create your own custom profile to go and disallow certain classes from bootstrapping. This is really useful for restricted environments where, let's say, you can't do I/O or any file activity. Inside that if statement, you'll see this pattern over and over again for each core class. It'll mention, it'll call a static method based on the same name as that Ruby class, Ruby array, create array class. And what this method does is it bootstraps the core class itself, and that's its responsibility. So let's dig down into that. If you look at the first line here, runtime.define class, okay, that makes sense. It's called array. Its superclass is object. Remember that runtime get object. And it has an array allocator. I think I'll leave that to your imagination. And then if you look at the next line, we include module enumerable. So this is very easy to read. And one of the first problems that people have when they start working on JRuby is they think that Java inheritance dictates these relationships, but in fact it's these simple methods in the bootstrapping class. And I'll talk about Java inheritance and how that fits in just a minute. So by the time you're done bootstrapping array, you have an instance of a Ruby array class whose name happens to be array. There's a superclass field that points at enumerable and a superclass field that points at object. For anyone who's ever actually read through the Pickaxe book, this diagram looks very familiar. And that's because these methods are just representing Ruby relationships. So the next thing, there's a line that's typically in every class called define annotated methods. What define annotated methods does is it takes a class, it scours that class and looks for @JRuby method. That's the purple link there. And what this annotation does is it takes the Ruby method name, in this case length, an alias of size, and binds it to the Java method that's there. And so this is how we produce bindings between Ruby method signatures and Java signatures. In fact, it's quite a bit cooler than that because you can actually have multiple JRuby method bindings binding to the same Ruby method. In this case, these all bind to insert. You'll notice at that top insert left out name, we just default to the Java method. You'll also notice that the first three insert methods take an array of 0, 1, and 2. And we do this for one of two reasons. The first one is for performance. If you're actually, let me just cover the fourth one really quickly. So the first three are 0, 1, and 2. The fourth one pretty much catches everything else. And if you look at that annotation, there's one required argument that has to be there, and it accepts basically a REST argument style pass. The reason why we don't do everything like this fourth one is because we don't want to box arguments. So when we actually call the 2-argument version of this method, the third one down, we can literally pass argument 1 and argument 2 straight through without having to allocate a primitive array and then set each element to that value. And that makes things a little bit faster. Doesn't make them a lot faster, but every little bit counts. One other thing that you can do with JRuby method is you can actually pass in block when you actually want to have a block accepted in the signature. Even if there's no block passed in, we still use a null pattern, and so you can still call isGiven on the block and determine whether it's used or not. So up to this point I've covered kind of the static side of defining Ruby core classes and how you set up the relationships for inheritance and setting up modules and so forth, and defining the methods. But I'm going to explain why most people get confused by JRuby's source at first. So by the time you're done bootstrapping, you'll have an instance of something called Ruby class. It'll have that name array on it. But if you actually look at the Java inheritance hierarchy, you can see that it extends Ruby module, which extends Ruby object, which extends Ruby basic object, which is a little strange, but we support Ruby 1.9 as well as 1.8, so it sort of makes sense. And then they all implement iRuby object. So whenever people start working on their project, they always just assume that this is how these relationships are set up. And in fact, like any object-oriented language, we just take advantage of inheritance so that we can share methods and state. So if in the array you're in a class method in array and you want to actually do a dynamic dispatch or call another Ruby method, then you have use of basic objects call method. And since Ruby class is a Ruby module, then you can make use of modules methods field or map, and then also make use of all the methods that know how to manipulate that map. And to really drive it home, and I suppose give a little bit more detail, if you go and construct an array, the allocator that I said it was left to your imagination will actually construct an instance of a Ruby array .java, and it'll go and populate this attribute called values with 1, 2, 3, and 4, fixed nums, And then it'll define a bunch of methods that are useful. And this can be used by other classes in the Ruby runtime that can cast this object into a Ruby array. If you look at the very top line, this is what the first thing that you sort of notice when you start working on JRuby. You go, oh, it's a Ruby array. Oh, it extends Ruby object. Well, of course it does. An array extends object. So those methods in the slide 5 or whatever actually defines those relationships. Another thing that people typically run into issues with when they first start working with JRuby, or should I say, one of the first questions they always ask is, why is everything named iRuby object? Well, every single object in the system from a Java perspective implements the interface iRuby object. That's actually a Ruby object. So it's the common base class for all objects. So why have this generic object everywhere? If you call something that's supposed to return a fixed num, why doesn't it return Ruby fixed num? Well, the truth of the matter is, in the Ruby language, almost nothing does. Something will typically return that type, or if no changes occurred, then it returns nil for some reason. So it's just much easier just to always return iRuby object. And likewise, for arguments that you pass in, it's even more likely that it's got to be iRuby object because it might accept fixed num by default, but it might accept any class at all because it's going to call toInt on it. And the truth of the matter is people aren't too impressed when they first look at argument handling, and it is kind of a mess, but I want to blame MRI. A little bit. MRI is not entirely consistent. You'll be working on a bunch of methods in fixed num, and they'll all do conversion with toInt, and then all of a sudden you work on like plus, and all of a sudden they don't do it. Why don't they do it? I don't know, but that's just the way it is. And they're also inconsistent. You'll be working on classes, and everyone will be using toInt as you're supposed to, and then in actual MRI or the C implementation, you'll see a class where they use toI. Again, I don't know why. And, well, actually, I have some theories. The first theory is that MRI wasn't built around a spec. It was organically grown. And I think as a result of that, not having a huge test suite like Ruby spec allowed a lot of mistakes to get entered in. And if you actually look at 1.8 and look at 1.9, they've actually fixed a number of these. So I don't know how much we can thank Ruby spec for that or not. But it's organic software, and we've had to be as compatible as we can, and compatibility is rough. But I will actually lay a little bit of fault on our end. Sometimes we'll go and put in an argument. We'll handle an argument and check to see whether it's a fixed num really early, because we know that it's incredibly common that fixed num's passed in right away, and we want to do an optimization. But then we don't add a comment, so people don't have any idea why we added that. And sometimes people submit a patch, and we don't think about it very hard and just commit it, and it works. They're doing the right thing, but they could have called a better method for it. So now I'm going to go over one argument handling example. And I sort of have two motivations for doing this. One is just sort of have you see the source code and see whether it intimidates you and how well you can follow it. And the other one is just to sort of talk about basically how much coercion and argument handling that Ruby actually has in the language itself. And then a few weird asides that I noticed when I was looking at the code, because that's fun. It's fun to me. The first thing I noticed is that there was an assertion at the top of the method saying, is this running in 1.9 mode? You'll notice at the annotation that this is marked as a 1.8 compatibility flag. How could that ever possibly happen? Well, someone went and added another JRuby method with a Ruby 1.9 compatibility attribute on it, and then in Java they just called aref. And so then they entered into They called a 1.9 method that expected to do 1.9 aref semantics, and then it started doing 1.8 semantics and probably confused the hell out of them for about 4 hours. And then they got angry and put an insert in there. The next thing is actually an uncommented optimization. We just check to see if the argument's fixed num, and if so, we deal with it directly. The third thing is just some wacky MRI error message that we tucked in there. It obviously isn't following some standard coercion rules. And I also wondered why it wasn't an aref common. Aref common is a method that's called both by the 1.8 and the 1.9 implementation of aref, but I'm assuming that this is one of those examples where over time they realized that it was just a wacky message and then changed it to be normal. At the very bottom, if it doesn't match these things, it goes to aref common. If we look in aref common, then it goes to Ruby range, which is a slightly less common type. Now you might wonder why we didn't just put this into aref. I mean, the first thing you could say is, oh, well, it's common. Maybe it belongs in 1.8 and 1.9, but there's a different reason why we did this. We try to go and make every method we can in Java as small as we can, where for the most part the things that are in that method are the things that happen most of the time. Because if that most of the time holds all the time, then Hotspot does crazy optimizations to it. And if the method is small enough, it actually just gets inlined into the call site. So you'll notice that we have lots of chains of common cases to uncommon cases. So going back to aref common, if it's not a range, then we ask it to go and call into standard argument coercion logic. For anyone who's actually looked at MRI's C implementation, you'll see that num_delong is the same name, and our logic is exactly the same, but slightly reformulated to take advantage of Hotspot. Again, you'll see in this method, we check to see if it's a fixed num, otherwise we call something else. We actually hand-tuned this until we saw it start inlining. In this particular case, our instance of fixed num was done in aref, but obviously since this is a generic catch-all for coercion from some type to a long value, it's got to be there. And it should be first, because it's the most common thing. But if it's not a fixed num, then we go to other_delong. Other_delong has a bunch of pretty strange cases for long. Nil, which is obviously an error. Float, which, what's the odds of that working? And big num, which is probably going to overflow in whatever you're trying to do. And last but not least, if it can't actually figure out that type, it asks the argument to convert itself to an integer. So if we go and look at convert to integer, then it calls convert to type, which is just a, I left out a method call here. Just pretend that convert to integer is just convert to type with a few more arguments, I guess. But it basically, this method goes and asks if the object can respond to the method in question, and if it can, it dispatches to it using Ruby dispatch, which is not very fast. However, when I was looking at this code, I realized that there's actually a case for an optimization here that might be worth looking into. Maybe it could be something that someone tried to contribute to the JRuby project. We could actually search for that method, and if it finds a method, we'll just call to it. Because right now, responds to searches through a hierarchy of classes looking for the method. And then if we find it, then we ask it to call method, which then goes and searches through the hierarchy of classes to find the method and then calls it. So hopefully this gives you a feel for what the source code sort of looks like. Arguably, this is probably some of the more ugly code we have. But if you can read this and follow along with it, you should easily be able to go and hack it. And it's not rocket science. What's my points? contribute to JRuby, and I mean it, contribute to JRuby. Realize that digging into any open source project always seems a lot harder than it is once you get started. Realize that our internals actually aren't that difficult to read. But I gotta pitch the book because 5 of us spent 2 years working on it, and it'd be a shame if no one actually saw it. So consider buying it. The people that have been in the beta program have really liked it, and we really do cover a number of details that are actually in this talk in regards to making Java native extensions. Things like the J method annotations are basically the same. There's a lot of good stuff in it, especially if you use Rails. It'll talk about deployment options, the ability to script Java from within Ruby. I'm sure we'll see some of that stuff tonight in later talks. Thanks.